Hi all, welcome to today's video. So today we'll be seeing further on perfect forwarding and some common pitfalls that can happen in perfect forwarding. So if you have not watched what is perfect forwarding and how it can be achieved via code, I would highly encourage you to watch my previous video on perfect forwarding. I will add a link to that in the top of this video. So continuing with some of the common pitfalls or some of the common errors that can happen in perfect forwarding are mismatched reference type. So mismatching reference types in the template parameter and the actual argument can result in compilation errors or unintended behavior. So how this happens is, in simple terms, if you use not a universal reference operator, which is this particular operator, if you use something else, like you add some specifier here or attribute or qualifier to this particular thing, and you remove that particular universal reference template, and then what happens is this will lead to a compilation error. Therefore, if you try to compile this particular code or run this particular code, it might result in the compilation errors. So it is not able to could not convert all the argument types, means it is not able to find a perfect forwarder function when we pass an L value and an R value. So if you just click on this particular error and go to the output window, you'll be able to see for which template type it is not able to find a perfect forwarder function. For example, with the template type as int, it is not able to find a perfect forwarder function for uh, R value. When we pass an R value, it is not able to find a forwarder function for it, since we are accepting an L value reference here. That's the error that we get. So you have to be just cautious based on what specifier you use and what it can result in. So that's one of the thing that you must remember. And the second most important thing is forgetting move, std move, when you are dealing with R values. So when you forget std move before forwarding R values, which can prevent forgetting to use std move before forwarding R values can prevent the conversion of an L value to an R value reference. So what it essentially means is, when you use an when this particular argument is an R value, not using std move when this arg is an R value, it can result in this particular R to be treated as an L value in the function. So it can create unnecessary copies when it is treated as an L value. Since the name is involved, the main thing to note here is the tip is, when name is there, then it will be treated as an L value. So this is kind of a bonus tip. If you're using a name uh, to actually access a particular variable, then that particular variable is an L value, not an R value. So this can happen only if you're dealing with an R value. So if you add this particular move here, which can prevent unnecessary copies in the case of an R value, when R is an R value type. So it can prevent unnecessary copies and it will be much more optimized. So processing of this particular function will be much more optimized without allocating unnecessary memory. For if you are using that for an L value also, this can cause an error. Therefore, this can cause an assert failure for STD forward. Therefore, if you try to build this particular project, now you will face error because you are not only passing or dealing with R values, you are dealing with L values as well. Therefore, if you go to the output window, you will see that when we are passing an L value, this is causing a error. Static assert failure it is causing. So let's move forward. So that's about this STD move. This is only useful when you are dealing with an R value. To prevent unnecessary copies, you can use STD move. So the other thing is, this is a basic thing. Therefore, if your intent is to do perfect forwarding, then you have to use std forward like this, not like this. When you use std forward like this and use a kind of a template type to cache that particular value and use it inside this function, the intended result might not be achieved because you are using a temporary variable here and that intended purpose may not be served. So if your intent is doing a perfect forwarding, always use the forward API HTTP forward in this particular context. That's what I want to cover in this particular video. Hope it was helpful. And there are some other real world applications of this perfect forwarding that I'll try to cover in the next video so that this video will not be so lengthy. So thank you for joining us today. If you found this video helpful, don't forget to give it a thumbs up, subscribe to the channel for more C++ content, and hit the notification bell to stay updated. So check the description below for links to the blog, and please feel free to share your experience with perfect forwarding or any questions you have in the comment section below. Thank you. We'll see you in the next